Welcome to The Explainer. Okay, today we're putting on our detective hats and diving deep into the heart of scientific research. We're going to explore how a new wave of, let's call them data sleuths, are working to keep science honest, and how you, yes, you, can actually adopt their mindset.
Look, we place a ton of trust in science, and for very good reason. But the main system that's designed to ensure its quality, peer review, well, it isn't the ironclad guarantee we might think it is. And don't just take my word for it. That's a quote from a former editor of one of the world's top medical journals, who flat out admitted the process has some serious, well-known flaws.
And if you want to see the scale of the problem, check this out. A huge analysis looked at over 2,000 retracted scientific papers. And what they found was kind of shocking. The vast majority of these papers weren't pulled because of honest mistakes. Nope. As you can see, more than 2/3 were yanked due to deliberate misconduct. We're talking fraud, plagiarism, things like that.
So this reveals a really fundamental problem. The traditional gatekeeper, peer review, was just never built to be a fraud detection system. It's really based on a foundation of trust that, as we just saw, is sometimes broken.
I mean, think about it for a second. Reviewers almost never get to see the actual raw data from an experiment. They're basically just reading a report about the research, not digging into the research itself. And these reviewers, they're usually volunteers, often totally overworked, who pretty much have to take the author's work on faith. Get this, one study tested this by purposely inserting 8 huge errors into a paper, and the median number of errors found by any single reviewer was just 2. Sophisticated, made-up data, it can sail right on through.
So, with that traditional gatekeeper kind of struggling, a whole new role has popped up to help protect the integrity of science. This is the age of the post-publication data detective. These are people who scrutinize research after it's already been published. And what these detectives practice is something called statistical forensics. Now, this isn't about attacking science. It's about making science's self-correcting mechanism even stronger. It's basically the practice of auditing the numbers, looking for those little telltale signs that something might be off, kind of like how a financial auditor checks the company's books.
And the key to all this is getting the right mindset. It is all about being a skeptic, not a cynic. And there's a huge difference. A skeptic is constructive. They ask, okay, is this true? And they're totally willing to be convinced by good evidence. A cynic, on the other hand, is destructive. They just assume bad intentions right off the bat and ask, what are they hiding? A good data detective is always a professional skeptic.
And the most important rule in the playbook is this one. Always, always assume an anomaly is just an honest mistake. The vast majority of weird things you find in papers are simple typos or calculation errors. Fraud is the hypothesis of last resort. You only go there when the evidence becomes absolutely overwhelming.
All right, you ready? Time to get our hands dirty. Your first forensic tool is one of my absolute favorites because it's so powerful and it relies on nothing more than basic grade school arithmetic to spot numbers that are literally impossible. It's called the Grimm test, and it works because of a simple, unbreakable rule of math. Just think about it. If you're adding up a bunch of whole numbers, like say scores on a 1 to 7 survey, the total sum has to be a whole number, right? You can't add a bunch of integers together and somehow end up with a fraction. It just doesn't work that way. And here's how you can run this test yourself. It's just 3 easy steps. First, you get the total sum by multiplying the reported average from the study by the number of participants. Step 2, you figure out that tiny little window of possibility that rounding creates. And then third, the final check, you just see if a single whole number actually exists inside that little window.
Okay, let's walk through a real example. So a paper says that 52 patients had an average anxiety score of 8.41 on a scale that only used whole numbers. Okay, so if we multiply 8.41 by 52, we get a sum of 437.32. Now, because that mean was probably rounded, we have to calculate the possible range for the true sum. In this case, it has to be a whole number somewhere between 437.06 and 437.58.
And here it is. Here's the power of the test. Just look at that range. Is there a whole number, an integer, between 437.06 and 437.58? No, there isn't one. The space is empty. That means the reported average of 8.41 is a mathematical impossibility. It's a huge red flag. Now, it's probably just a typo, but it is, without a doubt, an error.
Okay, so beyond just impossible numbers, data detectives also look for more subtle clues. These kind of unnatural patterns in the data itself.
You see, when people just invent data, they rarely do it in a truly random way. They often leave behind what you might call a human signature.
A really fascinating tool for this is something called Benford's law. It is a weird but totally true statistical fact. In tons of real-world sets of numbers, like financial records or even the lengths of rivers, the number 1 appears as the first digit about 30% of the time, but the number 9, it shows up less than 5% of the time. When people make up data, they almost always fail this test, because our brains think random means spreading all the digits out evenly. Nature just doesn't work like that.
Detectives also hunt for a practice called p-hacking. You know the saying, if you torture the data long enough, it will confess to anything. Well, that is p-hacking in a nutshell. It's when researchers, maybe consciously, maybe not, just keep analyzing their data in all these different ways until it finally spits out a statistically significant result, that magic p-value of less than 0.05.
And this can take a lot of different forms, like stopping data collection early as soon as a result looks good, or measuring 10 different things but only reporting the one that was significant. These kinds of practices create a scientific literature that is systematically biased toward exaggerated, exciting, and often completely irreproducible claims.
So, why does any of this matter? You might think this whole forensic mindset, all this intense scrutiny, is about tearing science down. But the goal is the exact opposite.
The goal is to help science live up to its own amazing ideal of being a self-correcting enterprise. It provides a much-needed accountability check that encourages more rigor and more transparency, and ultimately, it builds a stronger, more reliable foundation of knowledge for all of us.
So what should you take away from all this? Well, first, the scientific record isn't perfect. Peer review helps, but it's not enough. But the cool thing is, by adopting that data detective mindset of professional skepticism, you can use simple tools to become a more critical and informed consumer of research. And this scrutiny is a vital part of making science even better. Which kind of leaves us with a final thought to chew on. If we think of pre-publication peer review as just creating the first draft of scientific history, then who are its editors? Well, the ongoing work of data detectives, and now informed and critical readers like you, is what truly refines that draft, corrects its errors, and helps all of us get that much closer to the truth.